Okay, we'll get started. Unit testing saves your ass. Tronauts. My name's Jared Youtsey. Why should you listen to me? Because I'm old. In this industry, sometimes that's not looked upon very well, but it's true, I'm old. I've made lots of mistakes. There's another one. So hopefully, right, I've learned from those mistakes. You can learn from my mistakes. I'm old enough to know that coding isn't life, that I don't go home and spend all my time coding. I have family and I spend my time doing that. But it also means that, like Lucas was talking about, I'm a lazy developer. I want to do things right the first time. I don't want to have to go back and revisit problems and things. If you want to, most of my stuff's Angular focused, and so if you want to check me out on GitHub, it's 5 dice, because my last name is Youtsey and it's pronounced Youtsey all the time, 5 dice. You can always find my car in the parking lot. It says 5 dice on the license plate. It doesn't have dice in the remember. I've got more than 20 years experience in software development in all aspects of software development. For the past 8 years or so, I've been really focused on front-end technologies, whether it's ASP, ASP.NET, JavaScript frameworks, it's been UI focused, with a real interest in UX and why things matter to human beings. And for fun, like Lucas, I'm into 3D printing and stuff like that. This is my little mascot, my little octopus here. If you want to talk about any of those things afterwards, I'd love talking about that stuff too. But yeah, I don't spend a lot of time sitting around at home coding. So I'll have some questions for you guys who do. So let me ask you this question. Why unit test? Anybody?
Quality.
Why bother? Quality?
Catch bugs before they happen.
Catch bugs before they happen?
Refactorability.
Yeah, okay. Catching things when we refactor, right? Right. A lot of times, though, we unit test just because my boss told me so. I had to. Why? Why does your boss do that? Why does your boss tell you you have to unit test? Because your boss may not understand what you do, right? As a software developer, they don't understand how to measure you on code and things like that. So they want some number that means something. We'll talk about why that's not really a very valid thing. So when we think about why we unit test, we're going to put on our NASA engineer hats, okay? Let's pretend instead of writing software that we're NASA engineers, right? We're building rockets, right? Now, when we think about the people who use rockets, they really care about quality, don't they? Right? Alan Shepard, when asked about what he was most concerned about, was that the fact that every part of this ship was built by the lowest bidder. Right? That's a concern, right? You don't feel like it's a lot of high quality, right? And it's attributed to John Glenn, although I couldn't find proof that he actually said this, right? He said something similar. I felt exactly how you would feel if you were getting ready to launch and knew you were sitting on top of 2 million parts all built by the lowest bidder on a government contract. Right? Somebody's cutting corners somewhere, right? So definitely something to worry about. We don't want our users to feel like those 2 astronauts really did, right? Confidence is the one word that sums up a lot of the things that were said, right? Catching bugs before they happen, quality. Confidence sums this up. But thinking about it from a NASA perspective, who all's involved? So let's equate things in NASA with things that we do as developers. First of all, we want the astronauts to have confidence in the thing that we build, right? Our end users care about the quality of what we build. So here's Grissom and Young in the Gemini training capsule, right? They cared a lot about the quality of that thing that they were going to get into. The rocket, right, is the product that we're building. This is the thing that we want people to have confidence in. There's a name to your product, right? And you care about whether or not people think about that product and like it or not, or hate it. We really care about that. NASA, the name NASA, what does it mean to you? I know it means a lot to John. So, right, that's an important name to most of us, right? We take pride in what that name means. And yet, we don't work for NASA, but we care about it, don't we? So the company name matters. Your company name matters. When they think about when customers think about your company, is it a positive or a negative association? Do they have confidence in it? We want our fellow engineers to have confidence in us. I want to have confidence in my fellow engineers. I want to be confident that what they build is quality so that they don't mess up what I built, or that I don't have more work to do. Or I just like having pride and ownership that right, I care about my team and we work together and appreciate confidence in them. The nation and the government's involved too, right? The government's pouring money into it. National pride is tied up with the name NASA, isn't it? It's the national. It's national, it's in the name. So, right, the whole nation cares about it. We haven't in the past had nearly as many really public launches, right? But it sounds like we're gonna have a lot more, right? How long will it be if we're gonna be launching that often before people start making pilgrimages out to Florida just so they can go launch, right? I'm thinking about it. So our boss cares about our quality, right? Our investors, if we work for a bigger company, care about our quality. So they need to have confidence in what we do. Most importantly, right, I want to be self-confident. There's been a lot of talk lately. Did I skip over that one still? There's been a lot of talk lately about imposter syndrome, about I feel like I'm faking it, right? Well, this is something that helps overcome that, right? It's like I'm proving. I'm not faking it. I'm proving it out. I'm really doing it. So we want to have confidence in ourselves to a certain degree. Not overconfident, but definitely some confidence in what we're capable of doing. So then, the result effect of confidence is the ability to sleep well. You don't have to worry about a pager, if any of you remember what that is, going off in the middle of the night. You don't have to worry about your phone ringing and somebody going, production is burning, right? We want that kind of confidence so that we can sleep well. These astronauts here are obviously not overly concerned about what's happened in the past with the Apollo 1 fire and the Challenger disaster and the Columbia disaster, right? Those things happen, but over time we get better and better and better, and their confidence level grows to where they can sleep in the most hostile environment human beings have ever experienced. Okay? Confidence, that's what we're looking for. Testing leads to failure. Failure leads to understanding. I didn't know whether I'd be able to shout that loud enough. That's Yoda, in case you can't tell. The projector doesn't do a very good job there. But we want to understand our code. Part of having confidence in our code is really understanding how it works, why it works, and that it works. Have you ever written code and the next day gone back and looked at it and gone, man, what was I thinking? I can't even figure out what I wrote yesterday. If it hasn't happened to you, you just haven't been in the business long enough. It will happen to you. But when you think about that, right, when we write tests, we really have to understand what our code is doing. Right? We really have to be able to interpret what it does in order to make sure that the tests match up. So we do a better job of understanding our code when we write tests, which gives us a higher degree of confidence in it, because it's not like, I'm not really sure how that works, or I'm afraid to touch it because it's fragile, right? We have gained the understanding that helps us appreciate that it's good code. So, you should love unit testing. Now, a lot of people won't tell you they love unit testing. Who does love unit testing? Oh, good. We have a good crowd of unit testers. That's good. I like this quote by Benjamin Franklin, that the bitterness of poor quality remains long after the sweetness of low prices forgotten. Yeah, we can all develop really fast, right? A lot of us can just churn out code. But when that code fails, how long does your customer remember when it costs them energy and time and frustration? How long do they remember that? How long does your boss remember when production went down because of that thing that you pushed, that you had to roll back out of production? Right? That's the bitterness of poor quality, and it lasts a lot longer than the telling your boss, it's going to take a little bit longer to build this because we want to write unit tests. Unit tests are more code. A lot of times they're more code than the code you wrote, but they're important to have that level of confidence going forward so that we avoid the bitterness side of things, because the bitterness side of things can affect us on multiple fronts. We have to watch out for something when we talk about unit tests, though. Bad unit tests are, in fact, way worse than no unit tests. Bad unit tests can lead us down a path of believing that we're a real astronaut, when in reality, we're just a soap growing on a bathroom mirror. They give us false confidence. It's actually pretty easy to write bad unit tests. And there's really reasons for that. And we look really stupid when we have false confidence, don't we? It's like, yeah, we wrote this cool thing, right? And yeah, it's great. We've checked it out. We looked at it, and then we put it into production, and it falls flat on its face, and it doesn't work. And we look ridiculous, right? Because we promoted it, right? We got behind it. We're excited about this thing we wrote, and now we look stupid, right? Because of false confidence. So we need to be careful to avoid that. It's interesting. After the Challenger disaster, Alan Shepard made a comparison between the Apollo 1 fire, which killed several astronauts, and the Challenger disaster, which killed 9?
3 and 7.
3 and 7.
3 for Apollo 7.
Alan Shepard said there were similarities between these two incidents. The similarity was too much success over confidence and complacency, quite frankly. So we want to be careful that we're not becoming overconfident because of bad unit tests, right? Because it can lead us to complacency. And a number one thing that can lead us down this path of bad unit tests, of complacency, of false confidence is coverage metrics. Coverage metrics are horribly deceiving. Now, I'm going to caveat this. This is true very much of frameworks. How many of you are JavaScript developers, front-end developers? Okay, or full stack? Okay, so right, most of us in the room. So all of us are writing some sort of front-end framework, right? It doesn't happen nearly as often in back-end frameworks, but it's pretty common in front-end frameworks where there's a life cycle, and you're not necessarily in control of the full life cycle. So life cycle events can happen underneath you. And if you're a Reactor View developer, I'd love to talk to you afterwards because I haven't worked in Reactor View to understand this. In Angular, I can prove this over and over and over again that this is a problem. But if you have anything that happens underneath the covers, or you fail to isolate your unit tests sufficiently, you can have this kind of situation happen. So let's talk about what this situation really is and how coverage metrics can lie to us. So we're going to demo here just a little bit. This is a code coverage report, and we'll actually take a look at the live one here. Got to work sideways. So after Don's talk, this is John Weiss. He's an educator for NASA. After his talk last year, I went poking through NASA APIs, and there's this near-Earth object database. All of NASA's APIs are open, right? You can call them all, and you can build applications and stuff. You just get an application key. It's pretty cool. And so I found this cool application, and I thought, well, I'm just going to rebuild it in Angular. So I did. I rebuilt it in Angular, and I'm just going to show you embedded into this. You can find it on 5dice on GitHub/5dice. The application's got a whole lot more in it, right? But in it, there's embedded this dummy route with this dummy component. And all this dummy component does is do a little bit of math in order to put pick out numbers, and it puts these buttons on the screen. This is like the coolest app I've ever done. If you click the buttons, they go away, and then there's a conditional that says, oh, there's nothing left, or there's no data left. So then, that's all this does. Nothing fancy. But let's look at the code for this. This is Angular. Doesn't matter. You don't need to understand Angular to understand this code. Ng-on-init is a life cycle method, right? So it's going to get called whether I want it to or not. I instantiate a component, and Angular creates it, and Ng-on-init gets called. I have no control over that. It just happens. Ng-on-init gets called, and it calls this get some data. This is my little function that just produces the numbers that go into the buttons and determines how many buttons get created. And it's got a flag on it that says even only, so I can filter them so that only even numbers show up and things like that. So, there's a couple different branches through this code and whatnot. And then, has data. That's not even called in this TypeScript code. Neither is delete. Those are both template, right? Those are both in the presentation side of this logic. None of them are in the code side of this logic. So if we move over to the code, to the template's pretty straightforward. We can see that there's a conditional up top. There's an if, right? And if there is data, and I haven't clicked all the buttons, right? Otherwise, it does no data and just shows me no data. And there's a for loop in here, right? So that for each item in my data array, I end up with a button. And I can click on delete and the buttons go away. Pretty simple code in my template, but there is a conditional and a loop, right? Things that are testable. And then if we, let's go look at the code coverage report. So here's my code coverage report for this component. And let's see. My ng on init, it has been tested. Get some data has been tested, although I've missed this branch and I need to do that branch. Has data has been tested. The only thing I need to test is delete, right? That's all I need to write a test for. I'm good. So let's go over and write tests. Let's go write a test. Let's go to our spec file and look. Uh-oh. Guys, this is what the Angular CLI generates for me. This is boilerplate. I haven't written any tests. I haven't written any tests. Now let's go back and look at this code coverage report. 87.5% of statements, 62.5% of branches, 92% of the lines are tested. Woo! Manager can look at that and go, we're doing great. As a developer, I look at that and I go, ooh, false confidence. Lies everywhere. Because a lifecycle event got called, and it called the things in that lifecycle event, it's called code coverage. It should be called code execution. It's not covered by tests. There's no test. The only test that is written was written by the CLI that says, it compiled. Good job. Out of the box, right? If I have no code in my component, out of the box, you're something like 37% tested just by generating the class with the CLI. 37%. You haven't done anything. A number doesn't mean anything. But our managers want numbers, right? You have to have 70% code coverage or 80% code coverage. What does that mean? What does that mean? So it's deceiving, right? We have to really think about that. And then take another step. There's a conditional and a loop and a function binding all in that template. Should you test those? Well, yeah. You're binding data in. Shouldn't you make sure you're binding the right data into the display? Absolutely, right? There is no code coverage tool that measures that, right? There isn't one. Let's go back to our slides there. Y'all would say, can't tell which one slide. So, coverage metrics can lie to us. This is much less of a problem in services, right? It's much less of a problem in back-end code because there's not as much lifecycle stuff that goes on. Although I imagine there are circumstances where you could find this happens. Yeah, I got executed and I counted it and I looked good. But the reality is it's false confidence. That's so astronomical. If your manager insists on measuring you based upon code coverage, explain it to him. Show him an example. And push for branches. Branches is a better number. Branches says, I have followed the logic conditions, right? As opposed to the lines of code. I've followed the logic conditions through the code. So it is a better indicator. There's a problem with that, though. Sonar doesn't measure it. Sonar reports on lines or statements, one of the two. Right? I haven't found one. If you found one, that's cool. Let me know. I haven't found a CI tool that will report on branches, and yet it's the better number. So think about that if you're getting pushed for that. And remember that if you have that separation of concerns, right? ASP.NET does this, right? You have presentation and code behind and things like that. If you have that separation of concerns kind of thing where you have template, presentation template versus code behind kind of concept, then watch out that you test the template too, because it's important. There's code in that template But most of our code coverage tools don't look at HTML files and go, oh, I need to cover code coverage. They don't understand. Hopefully we'll get there someday. So remember that code coverage metrics will lie to you, and that you have to be careful. So how do we mitigate this problem if we can't use automated tools? We do good code reviews, right? We have to be doing good code reviews. We have to hold each other accountable. What is a good code review? A good code review is one that compares what it's supposed to do with was it tested. It's not just about the code, it's about the quality of that code, right? Did we make sure, are we backing ourselves up so that if we refactor that code, tests will break, or the right tests are covering those scenarios, or covering that. So code reviews really matter. This is a joint group of American and Soviet scientists, engineers on the Apollo-Soyuz test project. They're examining a docking mechanism after they've tested it, right? They've done testing, and I'm sure they've got reams of printouts, right, of numbers that might mean something and whatnot. But in the end, right, the engineers all got together and they talked about it. They talked about what they learned. They talked about the pros and cons and what can we change, what's better, right? That human side of it, much more powerful still than any of the tools that we have available. So we want to make sure that we're doing quality code reviews. Now, I'm sorry, I can't make this next statement without saying it in the voice of Bruce from Finding Dory. Yeah. You know, fish are friends, not food. Okay? It is test behavior, not code. Test the behavior that's expected, not the code that got written. The code that got written should satisfy the behavior. If you test the behavior and you have code that's uncovered, what did you do wrong? Right? Something's wrong. If I have code, if I wrote tests for the behavior and the code didn't get covered, that code probably doesn't belong in my component or in whatever I'm working on. So, test behavior, not code. So, how do we do that? What is a good unit test? So, 3 things go into what makes a good unit test. First of all, we want to test the expected desired behavior. Happy path, right? We all know what the happy path is for our component, right? That's usually pretty well defined. So we want to test that the happy path works, right? Test for the happy path of going through this component. And test that your default values are set correctly, right? And that those things are set up correctly. Then we want to test the expected undesirable behavior, because things are going to break. We're going to get 500s and 404s, and right? We want to test that when an HTTP call fails, that our component reacts appropriately. We want to test when a user inputs an invalid value, that we display the right error message on the screen, right? We want to test that template side logic that presents the right thing in the behavior of our component. So we want to test the expected undesirable behavior. One other thing that we should watch out for when we test is extents and boundaries. So when we're testing with something that's an array, right, what happens if that array is undefined? What happens if that array is empty? If we're testing with min-max values, right? If we test that the absolute minimum works and that one less fails, and that the absolute maximum works and one more fails, right? We need to be testing those things to ensure that our boundaries are in place. Right? So those are 3 fundamental tenets for making sure you produce a good unit test based upon behavior, not on code. If it's hard to test, you may have architected poorly. Yeah, that's the guy from Indiana Jones. Can't see that one either. It may be that we've over-engineered a problem. It may be that we didn't follow solid design principles, that we didn't follow dry principles. We didn't think about you ain't gonna need it. Like I tested the behavior and there was code left over, you ain't gonna need it. Right? We didn't get rid of it. So sometimes we over-engineer a problem. We're explorers, just like NASA, right? We're going places nobody's been before, and I'm building this thing, and we don't get waterfall requirements like we used to, right? Where you got like reams of paper that had every little detail spelled out, and they thought of every corner case, and we don't get that. A lot of times we get like a sentence in a user story and a couple acceptance criteria, and we gotta go build a whole screen out of that. So we're explorers a lot of times. We're forging new territory and we're figuring things out. So we're not necessarily writing tests and figuring it out. If we were writing tests and then figuring it out, doing true TDD, we might come up with a better solution. But a lot of us don't do that, right? Let's face it, a lot of us are lazy. We're not good TDD people, right? Anybody here actually practicing TDD? Yeah, see, that's what I thought. I'm not alone. So we might use TDD, but we'll seek how. But if it's hard to test, it may be that we've architected poorly. We haven't really thought about it because we went to explore, and now we're in a tough situation. Another thing that can lead us down that rabbit hole is, especially in front-end frameworks where we are free in JavaScript to do whatever we want, good, bad, or ugly. If we don't have strong type definitions, right? If we're not leveraging something like TypeScript that enforces that on us, right? Or that, right? We're not leveraging the benefits that we get from something like strong typing out of TypeScript. In JavaScript, I may have a method that I'm passing a string to and a number to, and I get different behavior based upon which one of those comes in, and I get weird bugs that I can't find and stuff like that, right? When I go to look at that code to write a test for it, and I go look at it and I can't figure out what it does, sometimes it's because I don't know what the types are that are supposed to be coming into it. I don't even know how to write the test for it because I don't know what this variable name means. So strong typing can help you to write better unit tests as well. If it's hard to test and you're stuck in this situation where you're looking at this code, you realize that's not the best thing I've ever built. You might want to try TDD. Now, I'm not saying that you become a TDD developer tomorrow, that you do test-driven development starting tomorrow, that you always write tests first and then you write code to satisfy it. Right? They've been yelling that at us for years and few of us are doing it. So how do we use TDD in a really effective way? If you find that your code is hard to test, go write a test that works the way you wish it worked. And that test will break because, right, it doesn't work that way, but I wish I could use this like this. And then go and refactor your code to make the test work. That's the definition of TDD. You write a test that fails, you refactor the code until the test is green, right? And then you keep doing that over and over and over again. We're explorers, I get that, right? A lot of times we don't know all the requirements. It's hard to write a test ahead of time. We have to kind of go play with things and figure it out. So we have code, and then we want to write tests. If it's hard, take a step back and do the TDD way against code you already have. Write the test, it fails, refactor it, it goes green, you're good. And you probably will end up with better, cleaner, more understandable code when you're done. If you want to try TDD up front, you might have ended up with that anyways. But with the exploratory process, sometimes that's difficult. I skipped something earlier on, and I want to go back to it. This one here. How many of you are writing applications where people will die if your app fails? Yeah, me neither. Although, I work for a company that makes continuing education products for doctors. So, right, that's kind of up there. Tomorrow, you may be writing a healthcare application. Tomorrow, you may be writing something that runs on a vitals monitor that runs in a hospital. Right? Now, does the quality of your code really matter? You bet. You might be writing an algorithm for a self-driving car. Machine learning that has to make a decision about who lives, who dies. Right? Or who do I affect? Does your code affect anybody? Who does it affect? Well, if your code, if your customer is frustrated by your code and therefore won't recommend you when it's time to renew the license, right? That affects you, it affects your company, it affects your team, it affects your bottom line, it could affect your paycheck, right? There are other circumstances where we actually have people's lives on the line. Think about the guy who recommended your software to his boss. And they invested a lot of money in that software, and they got it installed and they got it running, and it hurts their business because your code quality wasn't there. and they lose confidence in your company and your product. Maybe their boss loses confidence in them. Maybe it affects their paycheck and their family's well-being. Maybe they're a Fortune 500 company. And maybe something that you did, a mistake that you made, meant they can't do business for a few hours and it costs them millions of dollars. That could affect whole groups of people. It could affect whole communities of people. If NASA makes a mistake, it affects the whole nation because we can't tear ourselves away from our television watching, right? So we do affect people's lives in a very, very serious way. We take it for granted that we don't because it's so abstracted from us, right? We have a tendency to not think about our user as anything other than a number of clicks and things like that. But right, we're getting into that persona-driven development, right, where we think about the people that we're affecting as real human beings. Well, we need to think about those people and their families and their job and their career and all of that, right? It comes back to confidence. Everybody in the chain needs to have that confidence. Otherwise, right, we're going to have a failure to launch, right? Nobody's going to be willing to fit the bill and put that rocket into space. So, unit testing. Unit testing gives us confidence. It's not the only thing, right? Tyler was talking about offline testing, right? That's another step in the process. And then, of course, we have full-blown E2E testing, right, that we want to do just to prove out that, right, all of the water will run all the way through the pipes, right? We need all of those things in order to have that level of confidence. But unit testing is a key part of that, right? It's the first line of defense before we get broader. It gives us confidence. It can save our sleep, right? It really can make the difference between I get woke up a lot or I'm comfortable enough to just sleep without worrying about what I just put into production on Friday night, right, over the weekend. It can save your users. We do affect people's lives more than we realize a lot of times. And so we don't want to be a pain to them. We want to help each other out. We want to care about each other. It can save our reputation, not just ours personally, right? Our paycheck's at stake, right? My manager looks at the quality of my work, and the higher it is, the more likely I am to get that next bump, right? To get that next promotion. And we all care about those things, right? It affects the reputation of our company. If people don't buy our company's product because they don't have confidence in it, then we may not have a job, right? So it affects our kids. Right, so our reputation is really vital. And just remember that unit testing can save your ass, sure not. Unit test all the things. Thanks for coming. Questions? Anyone?
I have a question.
Yeah.
So the company I work for, agency work, we do temporary contracts, we sell bundles of sprint weeks, put them back all together, do our best to get through as much of it as we can. How do we sell our clients on the value of this when they're looking at how many features are being delivered instead?
Boy, that's a tough one because in the end, right, your contract ends and they go their merry way. Right? I would suppose one way that you could approach that problem is thinking about it from the perspective of, well, so you have this flip side of, I can't tell you that I'm going to deliver a buggy code base, right? But as part of making sure I don't introduce bugs that are hard to foresee and complex problems, we do this, we slow down a little bit in order to do that up front, as opposed to after the fact, if something goes wrong and you have to call us to maintain it because it's something serious, right? I'm also going to charge you a fire charge on top of that, right? I'm not just going to charge you my normal, what I had negotiated a big contract before. It's like, the world's on fire, that's more expensive, right? So the bitterness of poor quality, right? You don't want to say we're going to give you poor quality. So you have this double-edged sword. So I would get my marketing team involved in wordsmithing that. But that's part of it, right? Is that, look, it's either investment up front or more investment later because it's software. We're engineers, but we're human beings, right? We're well trained and we've got a lot of experience. We do good work. But the reality is it's really, really complex. It's really hard. And there are problems that are hard to foresee. And the more that we take that hit up front, spending time analyzing our code through testing, the more likely it is that you don't have to make that fire call later to say, the world's on fire, our business is going down, you have to save us. All right, so yeah, it's a tough call.
One thing I found with explaining to like non-technical people about the value of unit testing, I don't know how technical the contract people are, is the artist metaphor. So if you see like on Facebook or YouTube, there are like videos of artists.
Here's what it looks like in 10 minutes.
Here's what it looks like in 10 seconds.
Yeah.
Here's what it looks like in 10 minutes.
Yeah.
Now, if a company is paying you for a number of pictures, right, then you can give them 100 of those 10-second like doodles,
Yeah.
right? Or you could give them, say, 10, 50, like really like high quality things. And sometimes that metaphor helps with people who don't actually know what unit testing is. They're just like, why can't you just do it right the first time? Right? That's what's why
No,
do you
maybe
need
there
to
are
use
bugs.
these buttons?
Yeah. Okay, that's a good one.
Yeah.
Thank you.
That's a good way of looking at it. Any other questions? All right. Well, thanks everyone. Really appreciate it. Just so much more, right? So big organization. Well, hopefully we'll get you back next year. The bugs are free.
Did he realize you were sitting front row in his audience? He was like, yeah, John Lee's right here.
No, I borrowed John's.
Oh.